Right. Welcome to this Open Security Summit session in December 2022. And here we're going to see one of the amazing OWASP tools, the OWASP ZAP. We're going to see one of the power users of this tool, which is Tiago. Show us what they do with it, right? And how to automate and how every company should be integrating ZAP into their pipeline. So over to you, Tiago.
Thanks, Denise. And also thanks for the invitation to participate on this event. I hope I can meet the high standards of the other speakers. I've seen a few talks and the quality has been great. So I guess questions will be left to the end of the session. So please, any question you have, share it on the chat. And in the end, I'll answer any questions you have. So let's start. So let's start with who am I and why I'm talking about security and scanning and all those things. So my background is basically on computer science and information security since way too long ago. I worked for the largest telco in Portugal, always in security roles. In the beginning, more as a developer. So I think that's a good start for any security professional to start on the developer side, to be on the other side. It will help them a lot later when they are more focused on security. Later, together with a friend of mine, with Nuno, we created the ZAP security team. So ZAP was like the Yahoo in the golden days with all those web applications for everything you can imagine. And it was a department with a few hundred people, more than 100 developers. And we basically created the security team from scratch that included pen testing, security training, both to technical and non-technical teams, participating in the specifications, implementing PCI DSS, all the things related with application security. Later, I also worked with Cobalt as a pen tester, but more recently, I joined these cool guys to create Probably. So this was in 2017. So Probably, just to give you a very short summary, is a Dust tool, is a scanner that runs in the cloud that automates the search for vulnerabilities, for security issues. Compared with other tools, its focus is more on the developers. So it can be used by developers and security professionals, but our approach makes it more friendly for developers to use. So we have an API, it can be integrated, we can be integrated with anything. And there's a lot of nice and cool features, but this talk is not about Probably. So, and this has been my role for the last years, mainly as a CTO, but sometimes, nowadays less as a coder in the scanner. So I still like to get my hands dirty in the code and try to fix some false negatives or false positives. It's always fun and challenging. And even more recently, so beginning of this year, March or April, together also with a group of friends and security professionals, we decided to restart the Lisbon OWASP chapter. So since then, I'm one of the co-leaders of the chapter. We already organized one meetup in Lisbon. We are hoping to organize at least 4 meetups during the coming year in Lisbon. So if you want a good excuse to visit Lisbon, come and visit the OWASP chapter meetups. You can even submit a talk. So we are always looking for talks. So feel free to talk with me or go to our website and submit a talk. You can share with the community. And by the way, just because I know there's a strong relationship between some of us here and OWASP, we decided to restart the Portuguese chapter that was kind of slowing down or dying because we want basically to help the community and give back. So I remember, I don't know, maybe for the last 15 years, OWASP giving a lot to me and to my colleagues and developers. And now is our time to also to share and give back and help. So I think one of the turning points was the OWASP Summit in 2011, and I know that one of the organizers, or the main organizer, was Dinis Cruz, which is here. And this was such an amazing event to see the browser heads of security all in the same room, discussing and getting to agreements on how to do stuff, seeing the birth of the mobile OWASP Top 10. It was great. So these kind of events, and later the OWASP 2017 Summit, now the Open Security Summit. It's not directly under the OWASP umbrella, but the spirits and the focus is the same. So these are the things that made us put our effort and free time into OWASP. So now let's stop talking about me and let's talk about the main subject. So to give a little bit context and put some bounds on the presentation, our goal is to share our scanning experience, mainly with ZAP. It's not the only scanner or tool we use and have been using, but is one of our most important tools. And we basically want to share some of the things we experienced, so others, of course, can benefit of this knowledge. So ZAP is an open source project. It's available for free for everyone to use. And we feel it only makes sense to give back a little bit after having using ZAP heavily. So in this talk, we'll basically talk a little bit about how we've been using ZAP, give some tools and some tips about how to use it in a larger scale, namely in an automated scale. So our goal here is not about using ZAP as a pen testing tool, as an individual, as a tool that is used to test a single application at a time, but instead how to use ZAP to scan hundreds of applications in a single day, and how to use ZAP in an automated fashion. Of course, all of this is with the goal of automating security scanning as much as possible, putting it in the pipeline, because we know, or a lot of us know, that security needs to be present every day, tests need to be more frequent, more automated, and this is a small step towards that goal. So to define scale, which I think is also important for everyone to be on the same boat, our experience with scale has been around hundreds, on the big hundreds of scans started per day. So in a 24-hour interval, we have a few hundred scans started on average. Some of them take minutes and a few take days. Just to give you some stats, a little bit over half of our scans are finished in less than 1 hour, and 80% in up to 4 hours. So this is, I think, are good numbers. They are not perfect if you consider this in a CI/CD pipeline. I'm yet to know to meet the developer that can wait 4 hours for a pipeline to run. So that really doesn't work. But we'll talk a little bit more about it soon. But I think these are good numbers considering how complex and big the applications are today. So why OWASP ZAP? First, it's open source. So being open source gives us the flexibility to modify it and understand how it works and improve it and so on and so forth. So as a company that does scanning, being able to control and modify the tools we use is important, because no tool is perfect, or tools have been built with different purposes, and there's always bugs, false positives, false negatives. So being open source brings the flexibility we need. It's also a tool that has a lot of quality. So it's a robust tool that has good outputs, and it's stable to run. It's very well maintained. So the ZAP team, especially Simon, have been releasing ZAP with very frequently. I actually gave this talk recently in another conference, and I always need to update this slide because they keep releasing new versions often. So this release is from October. It doesn't mean they haven't published new things since then. They have. This is just the release that they wrap around with the version number. So it's very well maintained. It's very well maintained. There's a huge and good community around it, which is also very helpful for us. And we also have a lot of internal know-how on ZAP. So we have a person in the team that is actively contributing to ZAP, so and participates on the merge request reviews. So of course, this is a win-win situation. It's funny that I'm showing here like stats about stars and downloads and forks of a tool as something also that brings credibility to the tool. I find it funny because recently I saw a talk that show how trivial it is to fake these stats for NPM registers. So it's really trivial to create, duplicate a software and fake all the stats to make it people to believe that it's real. This is not the case with GitHub, but it's I always take it with a grain of salt, these stats. So how do we use ZAP? So one of the things we do differently, maybe for most ZAP users, is that we don't use ZAP to crawl. So we already have our own crawler. We call it Anansi. It's internal, so it's not available to download. So we already have one crawler, and we're really happy with it. We are really happy with it. It's maintained internally by our team, built on top of Chromium, so it supports everything Chrome supports, so state-of-the-art web applications. So that's why we decided to keep using our crawler and not ZAP's crawler. And that decision had some consequences, but we'll get to that. So it's a crawler, very complete, supports weird stuff like Shadow DOM. It can detect pages that are similar, so we can save on scanning time, sequences, mutations, so on and so forth. Just for you to quickly understand what I mean by deduplication. Deduplication is when a web application has, I don't know, thousands of URLs that are exactly the same, only the content changes, like news pages. And it normally doesn't make sense to scan all of those thousands of pages. So we can just scan 1, 2, 3, or 4, and it's enough. It's a good balance between scan speeds and coverage. So, and this is what I mean by deduplication. We analyze the structure of the pages and use an algorithm based on CMash to exclude some of them. So, in short, we only use ZAP for scanning. So this means we use ZAP with an external crawler. So it means our ZAP has to receive HTTP requests from an outside crawler. It also receives valid sessions from the crawler. So we put the crawler in charge of authenticating and renewing sessions. This is always a challenge for scanning. This means receiving new cookies, new JSON tokens. We also receive some metadata about the requests, like this is a login page, this is a JavaScript file, stuff like that. So basically, our ZAP scans everything it receives. It's kind of dumb in that regard. It's the crawler that has that intelligence. So, and our ZAP receives inputs from the crawler, scans, and then needs to output. So we also don't use ZAP to view the vulnerabilities. So our ZAP is focused on scanning and exports or outputs the vulnerabilities to our own vulnerability management system. So basically, our ZAP outputs requests, responses, vulnerable parameters, methods, the usual stuff. Also, an evidence of the exploitation, something to give the user confidence that the vulnerability is real, and severity and CVSS based on some criteria. So one of the challenge we had when we start using ZAP combined with our crawler is that ZAP by default, if you start ZAP today and start a scan, ZAP will first crawl the application, and only after the crawl ends, it starts scanning. So first starts crawling, and then it starts scanning. So this means we might have a gap between the scan start that can be as big as hours, as large as hours, because the crawler can take a lot of time. And this is something we really didn't want to have. So we wanted scan to start as soon as possible, because we want vulnerabilities to start appearing faster. And normally scan time is a significant issue. So especially in the CI/CD, developers normally don't give tools a lot of time. They are not willing to wait too long for tools to run. So it was important to take advantage of every second we had and start scanning immediately after we have the first URLs. So, but this is not how ZAP works. So when we started developing, the easiest solution was to send all URLs from our spider to ZAP, have ZAP wait until the crawler ends, and then start scanning. So that's not good. ZAP is not also compatible with a scenario where we send them URLs in a stream, and ZAP scans as they appear. So ZAP is basically prepared to needs all the URLs in advance before it starts scanning. This is not true if you are using the interface, but this is how it works if you are using it programmatically or using its APIs. So just for you to have an idea, this means that if you would wait for the crawler, we would normally often wait around maybe 30 minutes, 1 hour. So the 90 percentile of our crawler is 1 hour for the crawler duration. So, but crawling and scanning at the same time has some challenges. One is interface. So if you crawl first and then scan later, you reduce the chances of the crawler messing up the scanner results, and vice versa. So having the crawler and the scanner at the same time can do damage, because the scanner is effectively already adding stuff to the application, payloads like comments, and the crawler is trying to keep up. So there can be even a scenario where we have an infinite loop where the scanner keeps adding stuff to the application and the crawler keeps crawling it in a loop. So this is something you need to consider if you go down this road. And another side effect of this decision is that because we want to start scanning as soon as possible, as soon as we get the first URLs, we have a limited knowledge about what we are going to scan, as opposed to a scenario where we have all the URLs and then we start scanning. In that scenario, we can look at the URLs and make decisions about, like, okay, these URLs are more important than the others, and start scanning those first. This is not the case when we have an approach like ours. Another requirement of it's not like a requirement, but it's how we use ZAP. This is all for you to have some context. We use ZAP, a dedicated ZAP for each target. So this is a very strong recommendation I do. Do not use the same instance of ZAP for multiple web applications at the same time. There are multiple reasons. One is security isolation. So imagine you are scanning different web applications from different customers. You don't want any security issue, any bug on ZAP or wherever to compromise, to give one site access to the other. Other is resource isolation. By keeping each target, each web application in each ZAP, you can better manage resources, and it's much easier to scale. It's much easier to launch 200 ZAPs than to launch a huge ZAP able to handle a lot of web applications. So it needs to be fully automated. So we use ZAP in a fully automated fashion. This means our scanner needs to obtain and keep a valid session. You know, when scanning web applications, that if we lose the session, our results are going to suck. There's no other way around it. So we need to make sure we have a valid session. We need to make sure there are no false positives. And yes, I know this is a bold claim. I'm not saying we don't have false positives. We do. We just have a very, very low rate. But when you are scanning at scale and in an unattended fashion, this becomes a very important issue. So you need to make good decisions and do good trade-offs, so you don't get overrun with false positives. And of course, you need to have good error handling and good feedback. So it needs to be also resource effective. After all, this is Java parsing arbitrary text coming from the internet. Yes, a scanner is basically a tool that it's doing text-based parsing on stuff and random stuff on the internet. So it's like the worst case scenario. And a scan can also take easily millions of requests to finish. And it's common for us to see responses, HTTP responses with tens of megabytes, especially on JavaScript files or requests with images. So you cannot just simply start scanning and not care about being resource effective. So before going into some specific problems and solutions, let me give you a short intro to how ZAP works. I already gave a few insights. So for those that have never seen ZAP, this is how it looks, or at least one of the screens. It's a tool, a scanner, or a suite of tools similar to Burp Suite Pro, like in many ways. I'm not going to say which one is better. I use both for different purposes, so I like both a lot. So ZAP is basically organized. We can look at it as organized in two big parts: the core, and the core is the part that effectively does the requests, that interacts with vulnerability management systems, that handles authentication, a lot of things. So, and we also have the add-ons. The add-ons are basically smaller components that typically implement small features like the SQL injection scan rule. So there's an add-on or that has the scan rules for SQL injection, for cross-site scripting, and those are on the add-on. So this, talking about GitHub repositories, the core is on ZAP proxy, and the add-ons are the extensions. So there's a few names for the same thing. So the ZAP extensions hold the ZAP add-ons that hold the ZAP scan rules that have the vulnerabilities itself. So it's really easy for you to play with just a single vulnerability with the code with the ZAP extensions repo. So this is a screenshot of some of the scan rules available on ZAP. So a lot of stuff in different stages of maturity, like stable, alpha, or beta. So the default operation mode of ZAP, the stock ZAP as you downloaded today, is to use scan batches. So ZAP grabs all the URLs it generates within its crawler and put them in a scan batch. Scan batch, and then it applies the active scan rules, like SQL injection is an active scan rule. It's active in the sense that it does requests with payload. So it applies that SQL injection rule at all the URLs of the batch, one URL at a time. Then it does the same for the cross-site scripting, for the cross-site request forgery, and so on and so forth. So it tests a single vulnerability at a time on a single URL at a time. And of course, you can configure multiple threads. So if you want to configure, if you want to increase the scan speed, you can say scan with 10 scanning threads. And this means basically that your ZAP will scan, will do 10 requests at the same time. So this is one of the scanning methods of ZAP. It also has the concept of the bulk scanning rules. So active scan rules are the ones that do, are some rules that do requests. Then we have the bulk scanning rules that run at the end when all the active scan rules are done. So examples of bulk scanning rules are the heartbleeds, cross-domain XML rule. So these are normally rules that are not, that is not relevant to scan all the URLs. It's only relevant to scan a single one, the root of the application. Stored cross-site scripting is also performed here because we need to have a view. We need to know all the URLs beforehand and check them all for the echoes of the payloads. And in parallel with all this, so active scan rules first, then bulk scanning at the end, and in parallel we have the passive scan rules. Passive scan rules don't do requests, are stuff like checking for application errors on the responses. So, and these run in parallel and normally take a lot of CPU. So imagine, just for you to visualize the thing, imagine you have a web application with 10 URLs, ZAP crawler found 10 URLs, and it created a batch with 10 URLs. So, and we have configured 5 threads. So basically, we can do, we can scan 5 URLs at a time. So we are doing 5 requests at the same time for these 5 URLs. And as the URLs are complete, we advance to the next ones. Eventually, we might run into this situation where we have only one URL remaining on our queue. All of the others are scanned, but this one was slower for some reason. And now you would imagine that we would be able to scan this URL doing 5 requests in parallel, but no, we are only doing 1 request in parallel. So this is an issue with ZAP when you are worried about speed and parallelism. The ZAP batches are kind of static. So if you have this scenario, you might have starvation and lose scan speed. But there's a few more slides about it ahead. So now that we have kind of a nice picture of how ZAP works, and we know our requirements, we might ask what to scan first. So since we are basically receiving URLs from the crawler, from our crawler as a stream, and we want to start scanning as soon as we get them, we are, of course, tempted to basically create a lot of batches of one URL. So the scanner receives a single URL to scan. Okay, let's create a batch of one URL and let's scan it. And as soon as we get another URL, we can create another batch and we can scan it. This because if we had batches of 10 URLs, we would have to wait for 10 URLs before it starts scanning. So this really doesn't work, or better, it works, but it's slow, because even if we say we want 10 scanning threads, if we create a batch with a single URL, we are only using 1 scanning thread. So there is no parallelism inside at this level. So if we have a really slow URL, this can block everything, and we are not really taking advantage of the multiple threads we want. So why don't we create multiple batches of one URL? So this is the ideal scenario. The scanner receives an URL, it scans it immediately. So multiple batches of a single URL. and we can create as many batches as we want, or up to the limit of parallelism or threads we want. The problem is that ZAP really doesn't support this. So doing this would involve a change in the ZAP core. So it's not on the extensions, on the add-ons, it's in the ZAP core. And trust me, you don't want to go there unless you really know what you are doing and you have a lot of time in your hands. The chances are that you are going to spend a lot of time battling with ZAP, and it will make your life really miserable as soon as ZAP updates the upstream, because either you are stuck with your ZAP with an outdated ZAP, or you basically struggle to keep up with the upstream because they keep updating it, and it's going to be really hard. So modifying ZAP to have multiple batches of a single, multiple batches, it's irrelevant the size of the URL of the batches. Modifying it for that purpose, it's not something we definitely recommend. It's really complex. And scanning also, having multiple batches would also have another bad effect of making ZAP try to handle re-authentication in parallel. So ZAP handles re-authentication, but by design, you can configure ZAP to check if your application is in session or not, and it does that for each batch. So if you would use multiple batches, you would probably end up with multiple threads trying to do re-authentication, and that will probably lead to chaos and situations where the sessions are lost. As soon as one gets the new session, the other is lost. So we basically did some experiments. This was really, there was a lot of trial and error here with this experience. So we tried multiple setups. One of them was, for the sake of simplicity, I'm using a round number like 10. So let's start with a batch of 10 URLs. This is a good trade-off because we only need to wait for 10 URLs from the crawler before it starts scanning. And normally 10 URLs are really are found quickly. So any web application easily has 10 links on its front page that don't require a lot of JavaScript or loading time. So it's easy to find those 10 URLs. So we could start really quick, sometimes within a minute. And it will give us a decent amount of parallelism, 10 threads. So this would basically look something like this. We would scan 10 URLs, and then we would queue the others and create a new batch after this one ends. The problem is, what if one of these URLs it's really slower? And this was something that happened to us multiple times. We had often looked at our scans and noticed the request rate has dropped and the scan was really slow because something like this. There was a batch basically just with a single URL, so doing one request at a time, despite we wanted to do 10, with a lot of URLs in queue for the next batches, but this one was really slow because it was slow on the application backend. So this is the equivalent of construction in Portugal. One guy is working, one thread is working, and the other 10 threads are basically sitting idle, 9 threads doing nothing. So this is not good. This is a waste of time, a waste of resources. So we had to try different approaches. We ended up reaching a balance between starting time, so the amount of time or the number of URLs we wait until we start scanning, and the starvation probability. So we ended up with numbers similar to these ones. So batches of 18 URLs. 18 URLs, we normally get it within a few minutes, 2-3 minutes. So we only waste 2-3 minutes of the scan, and with 6 threads. 6 threads because unfortunately, most web applications we scan cannot really handle a lot of requests in parallel. Our goal is not to do a denial of service attack, and most of the applications are in a production environment. So we need to go easy on the number of requests to make sure the application response time doesn't increase or the test environment doesn't go down. You all know that test environments are normally underpowered. So you as a security team, you don't want to take down the development environment, or else your developer is going to be pissed at you. And even worse, you don't want to take down your production environment. Although I would say that if a guy with a scanner can take down your production environment, something is wrong. But that's a whole different story. So this is the scenario we ended up, but there's still the possibility of starvation. So so these numbers were basically a result, a consequence of the analysis we did for this slide. So we ended up with an approach of grouping URLs by response time, and later by adding also the injection points variable. So the injection points, I think this is more a burp term. Injection points are the locations in the request where we put the payloads. So in this example, we would inject it in the instead of query, test, blah, go, and also even in the headers. Now I find this funny that I'm showing a burp screenshot in a ZAP presentation. Never mind. So basically, we noticed that most of the starvation was because the URL was taking longer than others. And there was 2 reasons for this. One was the URL was really slower, or the URL had a lot of injection points. And when I mean a lot, we've seen endpoints with hundreds of injection points, especially if it's a post with a JSON, that can easily happen. So we ended up by creating a simple heuristic where we multiply the response time by the injections points, and we get a rough estimate. It doesn't need to be really accurate, but we get a good estimate about how long that endpoint, that URL is going to take to scan. So we ended up with something like this, creating batches grouped by response time and injection. So of course, the first batch or the first 2, we cannot really group them as well because we only have a few URLs. But when we are about to start a new batch and we already have a few URLs in queue, we can do this group. And basically this means, in theory or ideally, all the URLs will take more or less the same time. So we'll always have the 10 threads running. So this is something that made a huge difference in the scan time when we stopped scanning URLs by the order we got them and started grouping them with these characteristics. So something else that can be done, and I think this is really important if your goal is to scan as fast as possible and if you are on a time budget, is to prioritize the requests you want to scan. So this is also smart because you probably, if you do this, you might get the juicier or more important vulnerabilities first or sooner. So some good approaches are scan first authenticated requests. Those normally have more vulnerabilities, more juicy stuff, because they are the ones that access the data of the users. Also prioritize requests with parameters, because most of the vulnerabilities on the web, at least the injection ones, it's a parameter that is vulnerable, although nowadays with REST, even the URL can be, the parts of the URL can be considered a parameter, but still most of the times we want to scan the ones with the parameters first. And we can even, within the request with parameters, we can scan some of them sooner than others. Those that do manual testing, pen tests, I'm pretty sure they, as soon as they see a request with an order by, or a page, they started scanning, they test them first, because those historically and statistically have had more vulnerabilities because they normally are connected with that database requests. So it's a good call if you are on a time budget, time constraint, and you want to get results and good results. Another important stuff is to delay destructive action. So if you can scan endpoints that do requests that do deletes, that do modifications, scan them later, because if you scan them first, most likely you are destroying objects on the application. So you are preventing yourself from then viewing those objects, which will probably give you a reduced view of the application. So leave scanning these kinds of requests at the end. Start with gets, then move to posts, patch, and then leave deletes, for instance, to the end. It's also a good call. Press the wrong button. Oh my God. Okay. Sorry. Okay. Yeah. My presentation is taking some time to refresh. So another thing that you need to consider when you are scanning a lot of web applications in an unattended fashion is authentication. You can choose to scan without authenticating. That's a decision, and it's something you can do first if you are new into this and you are starting to set up your pipelines and your automated scanning. It's a good starting point because you remove immediately one of the variables from the problem. But eventually you want to scan with sessions. You want to go deep inside the application and scan there. So some things you need to consider are that some targets, some applications might not allow concurrent sessions. This, fortunately, is not very common, but it might happen in very high-risk applications like banking. So if you have multiple threads and each one has a different session, that might not be allowed. Or even if you crawl and scan at the same time, like we do, if each component uses a different session, that might or might not be allowed. So this is something you need to consider, but most of the times web applications support multiple sessions. Some applications also, not very common, this is more if they have a WAF in front of them, detect the payloads, the malicious inputs we send, and kill the session. So this is really annoying because you cannot test anything. So the solution here is to ask the customer or to put your IP in an access list, so you don't have to go through the WAF. Otherwise, you are just spending electricity and time. It's not. You can scan with a WAF, but please also scan without it. Otherwise, it's just useless. And some applications have an idle or hard timeout that will kill your session. So all these things will eventually kill your session, and you will need to refresh a session. And of course, if your tool presses the wrong button, the logout endpoint, your session might be killed. So it's smart to have a list of endpoints with some heuristics like logout, logoff, exit, and don't go there. And always only go there. Right? Yeah.
Like delete database.
Yeah, delete database. That's also for a different motivation, but that's also a list that you should keep, especially if you are scanning in production. Depends on your level of risk. So there's a few good heuristics you can use to save you some trouble. Although if you want a very good coverage, you eventually need to handle those. Yeah, even if you can do it in a non-production environment, you are good. So, but in a production, you can also have multiple setups, multiple scan configurations, like the pipeline that goes through your production targets doesn't call posts and doesn't scans endpoints with delete. The other one does. So if we lose a session, we must ask a new one. But before asking for a new one, we need to know, did we lose it? And that's sometimes can be a hard question to answer. So the easiest way to do this, not the smartest one, is to check on every request. So every time your scanner is going to do one of its million requests, it will check first with another request. Let me check if my session is valid. So basically, this is doubling the number of requests you do to the application. So this is not really a good strategy. What we believe is a good strategy is to check every X requests or seconds, either at the crawler or at the scanner. So you can, we check it at the crawler, but our scanner also proactively asks for a new session to the crawler. And this is a good balance. Some of you might think, oh my God, but we might do some requests with an invalid session and lose some vulnerabilities. That's fine, because you need to consider, you need to look at this in a context of recurrent scanning, that you are scanning, I don't know, every day, every month. Okay, this scan, you probably missed a few requests because the session was lost at doing those requests. But most likely in the next scan, you won't miss on the same request. So eventually you'll have a good coverage, and eventually you'll be able to cover all requests with a valid session and scan. So these are trade-offs that we as pen testers, we really don't like them, because what if I lose something? But if we want to scale and scan more, we really need to start smaller and with assuming these trade-offs, and then slowly increasing, in this case, slowly decreasing the number of X, so we can check more often and increase the coverage. So this scanning at scale is all about trade-offs. Taking some seconds. Other situations you might want to consider or be aware, and this is something that can be done in the crawler or in the scanner, is to avoid testing or be careful when testing forms that change the password, because you don't want to lock yourself out of the application. And you won't imagine how many times our scanner or crawler locked itself out of the application because it changed the password. Fortunately, we know the new password, or removed privileges to the user because it crawled to the profile page and removed some privilege. So these are things that you can easily handle with a few heuristics. It will affect your coverage a little bit, but will make your life easier. Or deletes the user. So many times that we delete users or some other content. So some things you need to be aware. For instance, with SQL injection, you cannot just simply enable Boolean-based tests, because if you do that, you might end up with a situation like this, where you basically, you are not deleting the database, but you are basically changing the whole users table to emails to this value. So these are kind of settings that you need to be aware when you scan, well, even when you scan manually. But if you want to do it at scale, you need to be careful and disable these kind of things. So I'm kind of running out of time, so let me speed up a little bit. So about vulnerabilities. Vulnerabilities are the goal, are the thing we are looking for, but they are also the thing we hate the most. Especially
Tiago, you're fine, by the way. You can go past the hour. There's no problem.
Okay. I'll try not to go too much. Thanks. So most security tools, as most of you should know, produce a lot of noise. And that's kind of normal, because most of them are built for the pen tester, for someone that is doing a manual job and wants to be aware of all the weird stuff, like, I don't know, that request is missing the content type. Let me look at it. I don't think in reality people, pen testers really look at those unless they are like testing the most critical application on the planet. But the fact is that scanners produce a lot of noise. Either informational, so your web application has a certificate. Okay, so what? Your web application has an Nginx. So what? I only care if my Nginx is outdated. Most of the times, because we have time trade-offs, this is what we are concerned about. There's a lot of duplicated vulnerabilities also, especially if recurrent scans are not connected together. So we every time we scan, we need to go through all the findings again. And then there's the false positives. They take a lot of time to the security people, but put yourselves in the developer's feet and imagine going through 80 false positives in a list of 100 vulnerabilities. They don't have the knowledge, most of them. They don't have the time. So as soon as you make them go through that one time, it's guaranteed that they won't use your tool, whatever it is, again, because they just lost 3 hours trying to figure out why that missing char sets in a response is so important, and after all, ended up not being important. So we need to do some compromises, and again, it's okay, because the goal here is not to achieve 100% coverage. So automated scanning will never replace pen tests. We still need the human mind breaking the application. But the idea is to give you a very good coverage and make you feel, give you a better life as CISO between pen tests. So it will, if you can automate testing, you can offload testing to the developers. You can give more time, free some time of the security team, and you have a much better visibility of your risk, and you can lower your risk between the pen tests. So these are all trade-offs. So first of all, drop informational. Don't do the error of setting up your tools, especially the automated ones, the ones at scale that will produce a lot of results. Please disable as much stuff as you can. Disable informationals, because let's be honest, as soon as you do 3 scans, you'll probably have 200 of these. You won't have time. No one will have time. So let's ignore them. Let's focus on the things that matter. Let's focus on SQL injection, for instance, or I don't know, an outdated WordPress. Also, try to make your life, the developer's life, easier. So, and this can be done in a lot of ways. So if you put ZAP, imagine you set up your ZAP in your CI/CD. You can do this without modifying ZAP. You can do this like as a post-processing of ZAP. So you run ZAP, ZAP produces some noise, and then you can have your script in your favorite language in Python that looks at the vulnerabilities and remove the informational, remove duplicates. So like, for instance, if you have directory listing, you probably are good enough reporting just the topmost directory. It's completely useless to report all the others, because you normally, like 99% of the times, it's just a configuration for the whole server. So report just one of them. If by any chance there was actually multiple configurations, if the developer fixes this for this scan, this will come up on the next scan. So you are good. Remember, you are scanning frequently. So even if you miss something on the first scan, other scans will likely pick it up. And for instance, cross-site scripting, especially some parameters like page, you probably know this immediately, that, okay, if it's vulnerable on this parameter, it's probably vulnerable on all pages. So you probably can get away with reporting just a single vulnerability instead of on all pages. Something we also did, and this is something you should look at it if you are using tools like Burp, ZAP, is false positives caused by delayed based testing. So tools like ZAP, one of the ways they look for vulnerabilities is to send a payload, for instance, a sleep 10. It can be a command or operating system command or a SQL command, a sleep 10 that if the application is vulnerable will make the response time go over 10 seconds because the application is doing something that takes 10 seconds. So this is the default operation, but this will generate so many false positives because the application is slow, because the scanner was doing more requests, because something. This is something that has been plaguing security tools for ages. And there's actually really good things you can do, even again outside ZAP if you don't want to go modify ZAP, which are like if you get a vulnerability reported like this, okay, let's test it again. Let's do it with a bigger delay, 20 seconds or 15 seconds. The likelihoods, most likely, that will save you from reporting some vulnerabilities, because if you do it at a different moment than the 10 seconds test, you probably the service might not be slow. So the previous request took 10 seconds because the server was slow. But if you do the one that takes 20 seconds a little bit later, maybe the server is faster, now takes 2 seconds. Okay, one false positive avoided. This, of course, is more prone to server timeouts. So it might get you some blind spots, but you can also play with this by doing multiple tests. So our experience in the beginning, we started by doing an extra test, and then we still had a lot of false positives. So we increased the number of tests, and we start doing like 3 or 5 tests, like almost starting to doing a statistical analysis. So, okay, if I do 5 requests and 5 of them take more than 10 seconds, this is likely vulnerable. Still, we still have a lot of false positives because the application was consistently slower for that period. So basically, the solution that gave us good results was to interleave payloads with no payloads. So we do, I think, 5 a request with a payload, without a payload, request with a payload, without a payload, like a canary request. And this way, we can easily measure if the application is really slow or is just executing the sleep. So, and this reduced false positive rate a lot. It was great. And at first sight, you might say, okay, but you are basically, you went from doing 1 request to doing 5 clean requests plus 5 requests with the payload, so 10 requests. So you might say, okay, you've multiplied your scan time by 10. No. First of all, this one only happens when there's already a good chance it's vulnerable. So when there's a request that is slow. And most likely, we won't do the 10 requests because as soon as we do a request without a payload and we see it also takes 10 seconds, we can drop it. So we can know, okay, this is not vulnerable, it's just the application being slow. And to be honest, it's not the time you take to handle false positives, you as a human, is much more valuable than the time, the extra seconds the scan might take because you did, I don't know, maybe an extra 1,000 requests during your scan. So this completely pays off because it saves everyone time. Other things that you can easily depends, but that we found that give good results are to try to do a simple exploitation of the vulnerability. For path traversal, trying to extract something like the pass.wd file is great because as soon as we we have this in our site, we know it's vulnerable, there's no questions, unless, and it happened, unless you are seeing a documentation page that is showing you a passwd file. So this is something that happens eventually with enough scale, enough time of scanning. You ended up scanning applications that have these kind of things. So you need to come up with strategies or different files or techniques like do a canary request and see if the evidence is already in the response or not. If it's already in the response without a payload, you cannot conclude that it's vulnerable. It's likely not vulnerable. And things that come with time are the heuristics and also empiric knowledge, like coding false positives. And it's really easy to slowly start coding some empiric knowledge you have and you gain during your professional life and scans in a file. So often scans report false positives like there's a private IP inside the file. And often is a pattern like this. So this is basically a JavaScript file with some object being defined there. And there are good heuristics you can use, like the content type, the file extension. So these are things that you ended up, that it's worth spending some time coding this knowledge to save everyone's time later. So talking a little bit about resources, ZAP is built with Java. I love Java. Most people hate it because the long function names and the resources, but most of the times I think it's just bad coding, because Java can be really fast and really effective. Despite that, ZAP can be really resource consuming. So ZAP by design stores every request for the last 5 batches. So if you are using the interface and scan, if you do 5 manual scans, it will save every request. So this can mean, can translate to a lot of space. We have seen ZAP files taking as much as 180 gigabytes during a single scan. So this is a lot, of course. Unless you want to modify ZAP core not to save this, you need to come up with strategies to save this. So ZAP really quick has a very nice defrag function, yeah, like Windows 95, where you can defrag this database and the results are really cool. So this is a graph from the memory, the disk usage of one of our scans. So every time we run the defrag, the usage goes down a lot. You need to balance how frequently you run the defrag, because it's resource intensive. So you cannot run it constantly. You need to run it periodically and also be prepared for some timeouts. But this helps a lot. This helps a lot if you are using ZAP programmatically. It took us a while to discover this. Also, you need to be aware of some rules make heavy use of regular expression. And there is a nice, not often overlooked vulnerability, which is regular expression denial of service. So eventually, if you scan a lot of web applications, you might end up scanning a huge JavaScript file that will make your passive scan rules that look for errors, for instance, take ages because there's constant backtracking. So be really careful with regesps. You probably need to improve some of them. Be careful with the quantifiers, otherwise you might end up with infinite loops. So to wrap up, ZAP, in my opinion, as many security tools, still requires a lot of security knowledge and time. If you are considering it for unattended scanning, so for a pen tester, it's fine. If you want to put ZAP in a pipeline and automate scanning, you need to spend some time trimming ZAP, disabling vulnerabilities, tests, thinking a little bit about how you manage the crawling and the queuing, so you can get faster results. So this is particularly important to filter out false positives. If you are scanning a lot of web applications, you really don't want to get flooded with vulnerabilities. Neither your developers. So your developers need to get the results clean without garbage. Otherwise, they won't like you. But ZAP is also a very good tool, a very good foundation if you want to build something. So I know there's a lot of companies using ZAP as a base, because being open source, being really easy to understand, it's great. And it's really trivial to grab a rule, a vulnerability, let's say command injection or XML external entity, and start improving the rule. So, and the community is great. The community is very responsive. They are a little bit picky with regard with merge requests with the upstream, but that also ensures that the code there has a good quality. So please engage with the community. Especially Simon is a great guy. And that's it. Questions now or later? Here is my email, my Twitter, so you can reach me whenever you want about questions, with questions.
So one question I had was about the retesting stuff, because you also can do individual retests, right?
Yeah.
And
so
that's a nice way to scale, isn't it?
Yeah, that's a nice way to scale. So especially when you are a developer fixing a vulnerability, you fix a vulnerability, you probably don't want to wait another half an hour, 1 hour, 1 day for a result. So we actually have a retest functionality, and this is something that if you think in the pipeline context, it's really great, where you can test just that particular endpoint and that particular vulnerability. And the way we design it is it tests that particular endpoint for that particular vulnerability with all the payloads. So even if the developer does a naive fix like blacklisting or equals 1, eventually other payload will get it. But that's a really great way to speed up pipelines and basically just do a scan with that single request. So if you give that possibility to your developers, it's great, because they have faster feedback and they can fix the vulnerability and get the results quicker without clogging the pipeline.
And then the other one that's really powerful is to use the integration tests, right? To already feed traffic to the scanner, so then the scanner starts to learn, right? How to reach certain places, or what is good payloads to use, and then to fuzz. That's
a great idea. It's something we actually don't support that out of the box trivially, but it's a great idea if you have, even as a pen tester, if you have an open proxy, or if you set up the developers pipelines with a proxy that goes to your ZAP, for instance, and basically that will save you the crawling time and will give you very good coverage, especially with very good values in the parameters, because you will get probably the right values in the right places. So that's a really smart way for you as a pen tester or you as an automated security engineer to get coverage. So a really nice setup I can imagine is the CI/CD, the functional test, the integration test from the developers. Go use a proxy that feeds your scanner, and your scanner is basically just scanning whatever goes to the pipeline. So it's a really smart way to get coverage and save you a lot of time.
Yep. Yeah, absolutely, right? Because that's when you really can scale on the, especially on the QA side, because I know that you have to be careful with some of the testing in production, but ultimately we should be testing production, because like you said, if a scanner brings the production down, you have worse problems, right? But there's also tests that you probably want to do and have coverage, especially on when you can spin up an environment, test it, and destroy it, right? That's super powerful.
No, that's great, especially because it gives you a very good coverage in the sense that the integration tests are probably much smarter than your crawlers. So the integration tests likely have good values in the inputs, and also bad, I hope, if they are really good tests. So that will give you a awesome coverage. And sometimes, because they are integration tests, they'll probably give you the exact sequence of HTTP requests that you need to reach a certain state or a certain request. So if you grab those that stream of requests from the integration test, you probably can get to the right situation, and you can test that endpoint, which is something harder to do with a crawler.
Yeah, absolutely right. And then you know the integration with something like Jira or bug tracking system is also quite critical, right? Because that's also a way to scale that analysis, right? Like you said, you know, you want to do triages, and once you've done the triage, you want to make sure that you store that, right?
Yeah, completely. So in my opinion, the security tools need to work with the existing tools. I don't think it's a good idea to force the teams to use Burp or ZAP or whatever, or even probably it's great if you can integrate with a Jira, and so the developers get the issues on the same place they already get their bugs or some other things. But if you start doing that, my recommendation is start doing that only after you are comfortable with the volume of stuff you report. So it will immediately, the project manager and owner will probably kill you if you fire a scanner and send everything to the Jira. So do small baby steps. Start the scan.
So I would send it to a security team Jira first, or one that the security team controls.
No, but that's not scaling. You are not saving your time. I would, no, but in the beginning, yes.
That's what I'm saying. In the beginning, right? And then the ones that you want to move into the pipeline, that's the ones you make the connection, right?
Yeah, enable just SQL injection, send them to your Jira, and eventually a month later you can send directly to the other Jira, and you probably can get away with a false positive rate low enough so the developers still like you or don't hate you.
Exactly. All right, man, brilliant. I don't think I got any other questions. So look, thanks for doing this. It's really cool to see, you know, things at scale, and definitely, you know, I feel the pain on some of those cases where the scanner goes and blows up half the application, right? If you're not careful.
Just trying to help people making stuff better.
Absolutely. Brilliant. All right, good stuff. Thank you, man.
Thanks, Dinesh, for the opportunity. Thanks, everyone. Bye-bye.